that whenever your base is greater than 1, you'll have growth. Okay, for example, this was the graph of y equals 2 to the x, y equals 3 to the x looked like this, and so forth. But if you were to do something like y equals 1/2 to the x, what would that graph look like? Well, you could think of it as 2 to the minus 1 to the x, see? In other words, you could think of it as 2 to the negative x. In other words, it's a reflection over the y-axis. And it's going to look like a decay. So you can see that when the growth, when the base is greater than 1, like 2s and 3s and stuff like that, it's going to be a growth. But if the base is less than 1, you can see that really just means it's reflected over the y-axis, and it's actually a decay. So when the base is greater than 1, we have growth. When the base is less than 1, we have decay. All right. So this is why I never made a real big deal of decay graphs, is because you can always rewrite them as growth graphs reflected over the y-axis. So I didn't see any point in teaching like a big section on this. After the rewrite, it's not any different. It's just one transformation. Let's look at this compound interest formula. So you've probably seen this before. You're supposed to see it in Algebra 2. Hopefully you saw it. If not, it's not very hard to use. It's a little hard to memorize, but this is sort of your starting amount of money here. Okay? And then R represents the interest rate. It's an annual interest rate. And that's usually going to be given as a percent, but you want to put in a decimal here, not percent. Okay? And I'll explain in a minute, actually. T is time. Time elapsed. T is time elapsed. So, if you waited, let's say you put your money in the bank and you waited 10 years, T would be 10. So T is time. Then there's this N. This N actually shows up twice in the formula. Once in the base, well, in the denominator of the base, and once in the power. So the N shows up both here and here. This is the compounding method that the bank uses, or the credit card company uses. And I usually just look for the adverb in the sentence to figure out the N. For example, in this first example, see the adverb is monthly. Right, ends in ly, so it's an adverb. And that would mean N is 12. So for me, finding N is really easy. I just look for the adverb. Suppose it had said daily, what would you use for N? 365. See? If it says quarterly, that's 4 times a year, you'd use N equals 4. So this is just the number of times. What's going on is the bank looks at your money, right? So let's say this is your money. And some banks look at it every day and they say, ooh, you got that much? Let's give you a little more. This is a bank that compounds daily. The next day they come back, ooh, you got that much? Let's give you 2% of that. Come back the next day. Oh, you got that much? Let's put a little 2% of that back in. See?
Interest.
Some banks actually do this every month only. So every month they come by and they're like, okay, you have that much? And they add a little bit. See? In the end, it doesn't really matter how the bank compounds. It doesn't affect your balance that much. But some banks do it every month. Some banks do it every day. Some banks do it every minute of every day. Right? But the point is, you can tell what N is by just looking at the adverb. Okay? So anyway, this problem's actually pretty simple. It's actually more about borrowing money. It looks like somebody spent $3,000 on their credit card and didn't pay their bill for 2 years. Okay? So let's see what happened here. So this is the growth of somebody's debt, you could say. It's pretty simple. We know that we started with a $3,000 debt. We know that this particular bank charges a 2% interest. You need to write that as 0.02. That's really important. Do not write 2 here. The compounding is monthly, so you're supposed to use a 12 for N. And the number of years is 2 years. Okay, so this is your T equals 2 right here. N equals 12 right here. R equals 0.02 right here. P equals 3,000 right in the middle of the paragraph there. It's pretty simple. Just type it in. Okay, so I'll give you a second to type it. Let's see how much this person owes, having not paid their credit card for 2 years. when it comes to typing the 12 times 2, just type the number 24. Okay? Because you want to make sure you don't confuse the calculator. You want the 2 and the 12 up in the power, so just type 24. Might be the safest thing to do. Okay, I got $3,122.32. You might want to round it up to 33 cents. It just depends on what the company wants to do. If they want to round it to the nearest penny, rounding up or rounding down. I don't really know what banks do with that. Doesn't matter to me too much. I don't use credit cards. So you can round to 33 or 32. I don't know. My guess is if you owe somebody money, they'll round it up to the nearest penny. But if they owe you money, they'll round it down. But I haven't tested that theory. Okay, the second question says, when will the amount owed be $6,000 if the person continues not to pay the bill? So this is a little bit different. This time you know that the final outcome is $6,000 and the input, remember, was $3,000. It's the time we don't know now. So this is still a 12, but there's a t here that we don't know. So this just becomes an algebraic exercise trying to get the t by itself, right? Yeah. Okay, so let's see, what would we do to get the t by itself? Well, first thing I would do is divide by 3,000. Okay, divide by 3,000. Okay, so if I divide both sides by 3,000, I get 2 equals, and I type this number into my calculator, 1 plus 0.02 over 12, and it's 1.0016666, and this just goes on forever. But I don't think we should retype this number. I think we should store it in our calculator as alpha b. Okay? So do me a favor, store this as alpha b. We don't want to retype numbers like this, especially a base like that. A base is a touchy creature. If you modify it even slightly, you've greatly affected the outcome. Okay, so we don't want to get this number wrong. We want to store it as alpha b in our memory banks of the calculator. So we're storing just the 1.0 whatever. Okay, now I would like to eventually get the t by itself. So I think I'm going to need to use a log. So I'm going to use a log base 1.001666 of 2. So the next step would be log base 1.001666 of 2 equals 12t. I plan on actually just typing b, not 1.066, whatever. Now we'll divide by 12. Okay, so t is log base 1.001666, etc., of 2 all over 12, which I plan on typing as ln 2 over ln b over 12. ln 2 over ln b, and then over 12. Okay, so this is what you're typing. Hopefully you know how. ln 2 over ln b, and then over 12. Does anybody not know how to store a value in their calculator? Okay, let me show you real quick. It's just a really accurate way to do it. Okay, so let's see here. Let's say you do 1 plus 0.02 divided by 12. And you want to save that number. Just press this button right here, stow. Okay, do stow. And then you're going to choose a letter of the alphabet. So let's use alpha B, because that was a base. And press enter. So the nice thing is now, instead of typing that number, I can just use alpha B whenever I need it. I was planning on typing ln 2 over ln that garbage, and then divide by 12. Now I can literally type ln 2 over ln b, and then divided by 12. So I'll just do ln 2 divided by ln alpha b, and then divided by 12. And it's 34.686. 34.686, and this is in years. 34.686. So my second answer to this question is 34.69 years. Remember, we round everything to the nearest hundredth in my classroom. So that means that if this person, Joe Schmo, neglects to pay their bill for another 35 years, they're going to owe twice what they started out owing. Okay. Does anyone know what's really ridiculous about this problem? In real life, I mean. Why is this problem kind of ridiculous in real life? Eddie? Yeah. Most credit cards don't charge 2% interest. They charge 13, 15, 17% interest or more. Sometimes they kind of trick you and they'll say, look, 2% interest for the first year, but that's if you pay all your bills. If you don't pay your bills, then it balloons up to be, 15%, 13%. You got to read the fine print, okay? If you do a credit card and you spend some money and you have this nice 0% interest thing, just know that that's probably temporary. Make sure you pay off that bill before this starts climbing. Once the base starts changing in this function, you're going to have some serious growth of debt, right? So
you wait 2 years, you can start paying yourself other functions too.
Yeah.
Credit scores.
Yeah, your credit scores, you lose a lot when you lose a little. So don't overspend, right? Okay, let's go to example 2. So example 2 is a little bit different. This is more of an honors level question. Same formula. This time the unknown is r. So it's a matter of isolating r. I probably wouldn't give this to an Algebra 1 class, or an Algebra 2 class even, but this is pre-calc. So this problem is a little different. This time the rate is unknown, okay? And it is $1,000 at the outset, and it ends up being $3,000 in the end. Don't worry about the word principal. That's not P. That's just how much is there in the end. Okay, maybe I should use the word balance there. But the point is you always put the final amount on the left anyway. So you do 3,000 equals 1,000, and then 1 plus r over n to the nt. Now we're waiting 20 years. What is the n? You've got to find the adverb in the paragraph. So where's my adverb? Daily. So what is n? 365. Okay, so we'll put that in here. So the goal is to solve for r. The first step algebraically is to divide by 1,000. Okay, so dividing by 1,000, we get 3 equals, and this is the 7,300th power. Oh my goodness. So we got to get rid of that power. We're trying to get r by itself. So I guess we're going to have to do the 7,300th root of 3. Yes? We'll fix it later. That's a good point. We'll eventually need to decide what to do with our r to make it look like a percent. That's a good question. Yeah. We will multiply by 100 in the end. You'll see. Once we know what r is, we can make sense of it. But let's go on. I need to do 7,300th root of 3. See? So you can type this if you want, if you know how. But I suggest we just do 3 to the 1 over 7,300. This is a lot easier to type. It means the same thing. Okay? And then we'll get a decimal on the screen. You don't want to round this number. It's 1.00, I think it's 0505. I don't know. It's a crazy number. It's really close to 1, but you don't want to round it. Okay, you don't want to round it. You want to subtract 1 from it, and then multiply by 365. Okay, well in any case, r turns out to be 0.0 what? 5491, something like that. So you just get this number on the screen, then do answer minus 1, and then answer times 365, and you get this. So let's make sense of this. This is supposed to be an interest rate, so you probably want to report it as a percentage. This is the decimal. So what percentage does this represent? You got to move the decimal over 2 spaces to the right to make a decimal turn into a percent. 5.49%. Let me know if you find a bank that's offering 5.5% interest. I'm very interested in saving my money there, okay? If I can find some money, I'll save it there. All right. Everybody see what happened there? So that one was a problem where you solve for R. And Algebra 2 students may or may not have the skills to do it, so, but I would expect you do. Okay, let's go on to the next example. So remember I was saying that some banks look at your finances and they say, they do this every day, they look at the bank and they look at your account and they say, oh, you got this much, let's put a little bit in, right? Some banks do that every month, some banks only do it once a year, I suppose. You guys understand that principle that they can look at your account whenever they feel like it and then add the money in? They don't have to do it every day. But when you sign up for the bank account, they'll tell you how they compound. Listen, never choose a bank account based on how they compound. It doesn't really make that much difference to you in the end. Some banks compound daily, some every 5 months, but in the end, it's like a few pennies difference. Okay? So don't stress about the compounding. But there is a type of compounding that's very important called continuous compounding. This is a little bit harder to understand. Imagine that your bank account is like a bucket, and it's partially full. Okay, it's got some money in here. Let's say there's $3,000 in here. Okay, and the interest is like a faucet. Okay, so here's a faucet. I can't draw a faucet very well. Okay, thank you. And the interest is always flowing into your account. Always. At first just a trickle, but as the 3,000 increases, and it will, this gets opened up even faster. In fact, the amount of flow depends on how much you have right now. This is called exponential, this is called, oh man, I just lost it. This is the law of exponential growth. So the rate at which the interest is coming in depends on how much there is in the bank right now. It makes sense, right? If you have a lot of money and they give you 2%, that's a lot of money. But if you only have a little bit of money and they give you 2%, that's only a little bit of money. So the way to think of this is the bank doesn't look every day at what you have and put the money in, or every month. They just have this little faucet, and it's just automatically being opened up more and more and more. And the money's just always flowing. It's continuously compounding. Okay, so the faucet analogy might help you understand it. And this formula will help you compute it. So here's a brand new formula for you. It actually looks fairly similar to the last formula. The A's on the left, the P's on the right. There's a base here. There's a power. Let's look at the differences between these formulas. The first formula you learned today was this one. And if you let n be large, that means they check very often how much you've got and give you the interest. Let's say you let it be 1,000 times a year that they check. That's 3 times a day. They look in your account and they give you the money. If you make n 1,000, this part right here that I'm circling in red is very, very close to e to the r. Very, very close to e to the r. If they do it, let's say, 10,000 times a year, it would be 10,000. That's like 30 times a day, I think. Anyway, it's a lot of times per day. This is really close to e to the r. And if you let n go all the way to infinity, completely, this collapses to the e to the r. So I'll circle it in red in the second formula. But if you take n and you make it very, very large, namely all the way to infinity, 1 plus r over n to the n becomes e to the r, for reasons I can't explain right now. Okay? So this formula collapses into something actually a little simpler. I like to think of it as the shampoo formula PERT. PERT makes shampoo. That's a company that makes shampoo. PERT plus shampoo. And it makes it easy for me to memorize the formula. A equals PERT. Okay? Also the faucet. Makes me wish I could wash my hair in money. Okay, so you've got the faucet analogy, shampoo formula. Hope you kind of understand this principle. It's actually really easy to do these problems because there's fewer variables. There's no n. So like on this problem, they're offering a 4% interest, so you can see that r is 0.04. It's compounded continuously. That tells you you'll be using this formula and not the other one. Okay? It says after 10 years, so this is your t. T equals 10. The only thing it didn't give us is p, so I guess we'll just leave it in our answer. So a is p times e to the 0.04 times 10, which I typed in earlier, and I got 1.49 p. Now, I don't know what p is, but it looks like whatever you put in, if you wait 10 years, you'll have about 50% extra. So 1.5 in mathematics means a 50% growth. That's what it means. So just think of it as, if you wait 10 years, you'll grow your money by 50%. And then you can pick any P you want. Put in 1,000. Put in $10,000 in the bank. It'll grow by 50% in 10 years. Okay. So I'm going to write that on here so you know. This means 150% roughly of P. So plan it up. Say, hey, I want 15 grand to buy a new car. That means you'll need to put in $10,000. Because it'll raise it by 50%. That's if you find a bank that offers 4%. Okay? And you have to wait 10 years. Okay. Let's go to the next one. Example 4. Suppose a bank offers rate 6%, so you should know right away that R is 0.06. Compounded continuously, what does that tell us? It tells us we're using the PERT formula and not the other one. Okay? If the amount in the account is $1,400 after 8 years, what was the initial amount? It sounds like we're going to have $1,400 in the end, but we don't remember what we put in the first place. It looks like the rate was 6% and the time elapsed was 8 years. So here you can see that it's P that's the variable, the amount we put in the first place. So this gives you 1,400 equals, and then I don't know what e to the 0.06 times 8 is, but I could ask my calculator. It's 1.616 yada yada, and I'm just going to do 1,400 divided by answer. So it's about, 886. No, 866. And round it to the nearest penny, 30 cents. So yeah, this grew all the way to $1,400 in 8 years. So, you know, if somebody gives you a big check on graduation day, and your grandma gives you an $866 check, throw it in the bank for 10 years, you'll get some growth. 8 years. Of course, you got to find a 6% bank account. That's hard to do. But the longer, if you go to the bank, you say, I'm planning on leaving this money for a very long time, they'll say, oh, let's put it in this account. This will earn a lot of interest. Does anyone know what they're actually doing with your money when you're not looking?
Yeah,
They're spending it. Yeah, they're actually investing and buying other things, and they're earning a return, and they're investing it. They're playing with your money to earn more behind your back, and then when you come back for it, hopefully you don't come back too soon and find out they've been playing with your money. They're not going to probably return it to you unless you come back when you said you would. And you just come back and they'll say, okay, well, here's your part of it, and we got a little bit of extra on the side. See? So they're playing around with your money while you're not looking. Sometimes they'll penalize you for taking it back too soon because you committed to a 6-month CD program or something. So anyway, it's good to talk money every now and then, learn how it works, right? Let's go to this. I do need to kind of start this a little bit today. I don't need to do example 6, but if I could start this one, that would be helpful because I don't want to have to do logistic growth too quickly tomorrow. It's kind of a complicated topic. So I want you to see that this formula here is pretty much exactly the same as the one I just gave you. A equals PERT. Okay? The only difference is the scientists don't call these A and P, they call them N sub 0, that's your P, and capital N of T, that's the number of bacteria in the end. So it's like money, it's like the starting amount, the ending amount, but they have new names. Also, instead of using R for the growth rate, they use K for the growth rate. But honestly, it's the exact same idea. So don't let this intimidate you at all, especially if you're not a science mind, okay? Doesn't matter, it's just the same thing. So let's try it. Here's our formula for number 5. It says What is the initial amount of bacteria? Well, that'd be 100. It's sitting right there. 100 bacteria. No work to do, just trying to interpret the formula. What is the growth rate of the bacteria? 0.04. Let's write K equals 0.04 because, well, this is a science question. So we'll use K instead of R. Huh?
Could we also write 4%?
4 plus N?
No, 4%.
No, we don't usually use percents on this. You could if you wanted to, but there's nothing wrong with writing 0.04 as 4%. You can do that whenever you really want to. But in science, we just write K equals 0.04. What is the population after 3 hours? So that one you'll need a calculator. You're going to literally type 100 times E to the 0.04 times 3. So make sure you type this as, 1 unit, like it's single quantity. I got 112.7 bacteria, but you can't have 0.7 of a bacteria, so I figured the 113th bacterium hadn't formed yet. So I interpreted this to mean 112 bacteria. So I don't think you can have half a bacteria. So I'm just going to go with 112. When will the population reach 1,000? So I'm just going to put 1,000 on the left, and this is 100 on the right. And now it's the time I don't know. So to get rid of the 100, I'll just divide. To get rid of the E, I'll just ln. And to get rid of the 0.04, I'll divide. So T is going to be ln 10 over 0.04. And you can get out your calculator and type that in. What is ln 10 over 0.04? 57.56 hours. 57.56 hours. Don't forget units on a science question, right? When will the bacteria double? Well, that just means 200 bacteria when we started with 100 bacteria. This one's almost exactly the same, except when you divide, you get 2 equals e to the 0.04t. And ultimately, when you solve, you're going to be doing t equals ln 2 over 0.04. So I skipped a step or two. And ln 2 over 0.04. Yeah, that's right, 17.33 hours. So I reached my desired stopping point for this. And I'll be giving you the assignment through Edmodo.